if theta equals 90 and if theta equals 0, what is the difference between the work in the two cases? Number one, if theta equals 90, we can find that work in this case equals 0, because 90 cosine 90 equals 0. And when theta equals 0, it means that work has maximum value, which is work equal F times D. F times D. Work has maximum value equal FD because cosine 0 equals 1. So work may equal 0 or may equal 1 if equal FD maximum value when theta equals 0, means work has maximum value which is equal force times displacement. And work equals 0 if the angle between the force and the displacement equals 90, because cosine 90 equals 0. This is the first point. If theta, this is another point. If theta is less than 90, it means that the work is positive. It is positive. If theta less than 90, it is, or the work is positive. And if theta is greater than 90, means the work will be negative. There is negative work and positive work. If it is positive, means there is angle between the force and displacement, and this angle is less than 90. And it is negative if the angle is greater than 90. And also in case of the force is opposite to the displacement, force and displacement are opposite, it means that the work also is negative. So the work is negative if the force and displacement are opposite to each other. This is about the work. Then we start to study what is meant by energy. Energy, you know that energy is the ability to do work. And unit of energy also is unit of energy is also joule or Newton meter. Unit of energy is joule. We will study two kinds of energy. The first kind of energy is number one, what is known by potential energy. What is known by potential energy? What is the potential energy? It is the energy stored in the object. It is the energy stored in the object due to its possession. This is the potential energy. And mathematical relation for potential energy equals mg d, where d is the vertical height from Earth's surface. This is d. And all of you know that m is the mass of the object, g is the acceleration due to gravity. So potential energy equals mgd, and it is a kind of work, because if you remember that vertical force, can be represented by F equal mg. Vertical means if the body moves upward or downward affected by the gravitational force of Earth. So F equal mg. So we can write that potential energy in this form equals force times displacement. So it is a kind of work. Okay? So potential energy is work. This is number 1. So as the height of the object increases, okay, its potential energy will increase. Means if we have two bodies, the first body has height h1 from Earth's surface. The second body has height h2 from Earth's surface. Okay? And they have the same mass. Which one of them has greatest potential energy? H2, okay, has potential energy greater than H1. Okay? Why? Because height or displacement, we can write H2 in the form of D2. It is the same. H1, it is in the form of D1, or it is the displacement. So displacement means height, and it is equal to, so the potential energy in the second case greater than its potential energy in the first case. Okay? Time. This is about the potential energy, and it is affected by the height from the Earth's surface. So any body on the Earth's surface, its potential energy equals 0. As it goes up, its potential energy increases. Means the energy stored in the object, okay, due to transformation of the kinetic energy into potential energy. Because when it moves upward, means there is kinetic energy acted on the body. This kinetic energy is stored inside the object in the form of potential energy. So the second kind of energy is kinetic energy. What is the kinetic energy? Kinetic energy, it is represented by Ke, and kinetic energy equals to half mv power 2. Half, it is a constant. M is the mass of the object. V power 2 is the square of the velocity by which the moving body moves. So any moving object has kinetic energy, okay? So kinetic energy equal half mv power 2. If we write what are the factors affecting on the kinetic energy, we can say that it is the square of the velocity at constant mass or the mass at constant velocity. Okay? We can write the graph we can draw the graph which represents the relation between number 1, the kinetic energy, if you remember, kinetic energy, and mass. What is the slope of this graph? The slope of this graph from the relation, okay, this is a relation, okay, this is a relation of kinetic energy. The slope of the graph equals half v power 2, okay. Then if we draw another graphical representation for the kinetic energy and the square of the velocity, okay, we found that its slope is half m, okay. This is the slope of the second graph. Third and last graph, if we represent the relation between the mass and 1 over v power 2, okay, we know that mass and velocity are inversely proportional, and mass and 1 over v power 2, its slope will equal twice kinetic energy. This graph is very important, okay? This graph is very important because many questions can be asked on this graph. So the relation between mass and the square of the velocity, its slope is twice the kinetic energy, okay? The last point we can study in this form, okay, that what happens for the kinetic energy of the object, okay, what happens? What happens if kinetic for what happens for kinetic energy of the object if its velocity increases to double. If the velocity increases to double, okay, it means that its kinetic energy will increases 4 times. It will increases 4 times its value. Why? Because the velocity is v power 2. So when it increases to double, the kinetic energy will increases 4 times at constant mass. Okay, this is from the questions which is very important. And this is about the kinetic energy.